Okay, this topic is very important for both foundation level, NEET and JEE level. Okay, now coming for what are the vectors? So vectors are those physical quantities which have both magnitude and direction. Okay, two terms are important here. What are they? Magnitude and direction. See, in physics we are having so many vector physical quantities. Okay, so vectors are empirical relations which are useful for us to understand a physical phenomena. Okay, like, so now for example a body is thrown a particular direction, so we are throwing this direction, so we can say the velocity of the body is v bar, like this. Okay, or some obliquely you are throwing some angle like this. Okay, then the body will go like this. We'll learn in next kinematics 2D motion. Okay, in that series you can see, so this angle is theta, some velocity you projected, you say. So here direction of velocity is given by like this tangent, here direction is given by tangent. So for a particle which is moving in a curved path, the direction of velocity is given, okay, along a tangential direction. Okay, so these things will talk in 2D motion. Okay, projectile motion will talk. So here for mentioning the direction, so we are using a vector. Why? Because like we have seen, for example in rainy season when you are bicycling, okay, when you are bicycling, the water droplets are sprinkled. Okay, water droplets are sprinkled in what direction? When this is particular is rolling like this, no, wheel is moving. Okay, these water droplets are sprinkled in this tangential direction, because at this instant these water droplets are having velocity like this, because of which they are what, moving in a tangential direction. Okay, so here velocity is in tangential direction. Okay, that's why we are representing as a tangent vector here, right? Similarly we can say sometimes a force is acting on a body of mass m, we call, right, like this. For example, a force F is acting or F bar is acting. So to mention direction, okay, we are using a vector called here force vector. You're following, right? So for example, a particle is going from point A to point B, okay, again then to point C. So while going point A to B, AB bar we call displacement vector, from B to C we call BC bar. And if I ask net displacement vector will be here AC bar. Okay, so this is you can call S bar. Like this, in our daily life to represent certain physical quantities we need the concept of vectors. Okay, and here vectors are defined as those physical quantities which have both magnitude and direction are called vectors. So actually strictly speaking in physics, the physical quantities, okay, so physical quantities are actually already we learn units dimensions, right? So fundamental physical quantities and derived physical quantities, that is one category. Under is we classify these physical quantities as vectors, okay, scalars, and one more is there, that is called tensors. We'll learn in higher classes. Okay, like you just stress you can call. Okay, so strictly speaking pressure also a tensor, we use the word. Okay, stress or pressure. Now currently we only focus on these two. Okay, now so vector has both magnitude and direction. Scalar has only magnitude. For example, you are saying rice bag of weight 25 kg, okay, or mass you can say here. Okay, 25 kg rice mass, here mass is what, a scalar quantity, only magnitude. Okay, so a force is applied on the hinge of, or on the what you can call handle of a door. So okay, fine, how you have applied, in what direction, how much you have applied, whether you are pushing the door or you are pulling the door like this. Okay, with what force, say for example some 50 Newton, or some you have pushed with 25 Newton something. So here both magnitude as well as direction is important. So these kind of physical quantities which require both magnitude and direction, they are called vectors. So examples are what here, you can say displacement is a vector, velocity is a vector, force is a vector. Okay, and few more you can add here, momentum. Okay, momentum is also a vector. So for example p bar, which is equal to m into v bar. Okay, again for higher class also we learn about certain other physical quantities like torque. Okay, torque tau bar we call. Okay, that is defined as the magnitude of the torque. Again we learn later, don't worry. So force into perpendicular distance. Okay, how do we calculate? Okay, now next in cross product I will be mentioning this also as equal to r bar cross f bar. Okay, next upcoming will understand, don't worry. Now this one. Okay, and then so we also define vector angular momentum. In chemistry also we come across with both. So angular momentum vector L bar is equal, again we call here r bar cross p bar. These again too I will make separately second part. Just I will briefly I will revise the synopsis here. Okay, in detail I will take in second series. Okay, now L bar is equal to r bar cross p bar. So its magnitude is given by students m into v into r. In chemistry we'll understand in Bohr's postulation the angular momentum of the revolving electron is given by mvr is equal to nh by 2 pi. Okay, where n is called an integer which is called Bohr quantum number. Okay, that we will study there. Now just currently just remember this is what angular momentum. Okay, we define separately how to calculate. Now our current motto is quick revision of vectors, just basics of what are vectors, what are okay types of vectors and all. Now vector means what, scalar means what. So just I will revise. See, those quantities okay which can be described completely only by means of their magnitude. Okay, they are called scalars, which require both magnitude and direction. If these two not sufficient, again they have to obey certain set of rules, laws. Okay, so they are called vector addition laws. Such kind of quantities, not only magnitude, direction, they have to what, obey vector addition laws. Vector addition laws. And those quantity students, okay, they are called what, vectors. So now coming for what are the vector addition laws, before that we try to understand types of vectors. Simple definitions are, so zero vector means a vector whose magnitude is zero. So for example a bar is a vector. Notation wise if you say, so it has both magnitude and direction, no? So this length of the arrow gives magnitude representation, and this direction, no, this arrow gives direction of the vector. Okay, so if you are having a vector whose net magnitude is equal to 0, no length, okay, zero vector. So whose magnitude is equal to 0 is called a zero vector or null vector. When it happens, you can see the simple example. Say you are going from starting from point A, you are going to point B, you are going to point C, again you are coming to point D. So this is starting point initial, you are going like this. Okay, say some O to A to B, again you are reaching O. So here again net displacement we can call. So there is no change in position. So already we studied displacement vector SR S bar is equal to, okay, so final position minus initial position we have seen, right? So here initial and final positions are coinciding. So from here to here, again here to net displacement we call 0. So to represent this situation we can say net displacement is equal to 0. So 0 vector, that is called null vector. Understanding? So when we calculate mathematically, if sum of all the vectors comes out to be 0, such kind of vectors called zero vectors. Say one more example also you can take, student, here. Like for example I have a body, okay, like this. Now I am applying an equal force. Okay, this side some 10 Newton I am applying, and this side also I am applying 10 Newton. In physics we say this vector is acting in particular direction. Okay, say do the right word, say positive. This acting equal in magnitude but opposite in direction. So we can say that these two vectors get cancelled, and net to sum of these two vectors we can call 0. Okay, this you can also call a zero vector. You're understanding? Yeah, like this importance of zero vector. Next about unit vector. So the name itself indicates, student, unit vector. A unit vector means a vector whose magnitude is unit. Okay, whose magnitude is unit is called what vector? Is called unit vector. Say to understand this one, try to understand that. For example, 2 is a number. You divide its own magnitude, 2 by 2, how much will you get? 1. Similarly here in vectors, if any vector is there, a bar, for example, notation, okay, we represent the vectors with what? Arrow marks like this, a bar, b bar, c bar, okay. And if you divide this vector with its own magnitude, student, okay, mod a, like the way you are dividing 2 with its magnitude 2, no, value is 1. Similarly, if any vector is there, if you are dividing with its magnitude, okay, what it gives? See, vector means it has both magnitude and direction. Say a bar magnitude is mod a. If I say a bar is equal to mod a bar, will it convey a beautiful meaning? No, because a vector cannot be equal to a scalar. Magnitude is a scalar. So how to represent this vector then? That's why we are writing this vector a bar as, which has magnitude, no? So mod a. What about direction? Yes, that direction is given by this unit vector, students. Okay, so that is into a cap. Now you see the whatever the meaning we explained before. A cap is equal to now a bar by mod a bar. Okay, this is what unit vector. So any vector, okay, divided by its magnitude, okay, gives what? Unit vector. So what is the purpose of this unit vector in physics? Keep in mind always, student, this unit vector is useful to specify direction. Whenever in physics we want to mention direction, no, we make use of this unit vector. So and its magnitude how much? Mod of a cap is equal to 1. How you are getting this one? That vector can be obtained by, okay, dividing it with its magnitude is called a unit vector. Okay, we'll calculate after components how to find, okay, unit vector. Okay, next will upcoming duration of time we will get it. Okay, this about. And then we talk about, okay, position vector. What is position vector? A vector which gives position of a, okay, what particular point or a particular object in a space can be called as a position vector. Now see here, for representing here position vector, a vector which gives position of a particle in space can be called as a position vector. See, always try to make use of a this coordinate system, students. X, Y, for example, this is origin. Say for example a particle or a point P, okay, or an object is placed at point P in the plane XY plane. So it has two coordinates, right? For example, X coordinate is 2, Y coordinates. That means distance from Y axis, X coordinate means this is 2 units, maybe meters, anything you can take, okay, unit, SI or CGS. Now this is for example 3 units. Okay, so now here O is a vector, P is the position where the object is placed over here. So the position of the vector, a directed line segment joining, okay, origin to the position, okay, is called a position vector. Generally we call it as R bar. Okay, so now this is what position vector. So a vector which gives position of a particle in the space is called a position vector. Again, we have different types, like we can call parallel vector, anti-parallel vector. Parallel means what? So here when two vectors are pointing in the same direction, okay, we call them as parallel vectors, like A bar and B bar. So for example, two vectors like C bar and D bar are there. So they are pointing in the opposite direction. Okay, they are called anti-parallel vectors. If their magnitudes are equal and directions also same, they are called equal vectors. What vectors, students, they are? Equal vectors. Say for example, in the same example, see here A bar is there, B bar. If I take their lengths same here, okay, A bar length and B bar length, if I take, I am point direction also same. I can say then as their magnitudes are same, length same means, and directions are pointing same direction mean directions are equal or directions are same. So I can call directions are same, no, so I can call them as equal vector. Therefore A bar vector is equal to B bar vector. Now it's a unequal vectors, okay, magnitude is not equal, directions not equal, any one of the condition is not satisfied, you can say unequal vectors. Okay, now and one more point you have to know here about angle between vectors, students. Angle between vectors. See, angle between vectors nothing but angle between their directions. Okay, because vectors means we're mentioning as what? Direction, no? So angle between the vectors nothing but angle between the directions. So for example, one vector is pointing like this, another vector is pointing like this. So what you do, as we have seen now already, see, as I mentioned, it's a revision, already you have concepts of vectors, but you can understand those who are new also for this. Okay, just I'm trying to explain the basics a little more also. Okay, now this starting point, this is ending point, initial point of the vector and final point of the vector, right? So starting point and ending point, tail and head. So you just arrange the vectors such that, okay, arrange the vectors such that the tails coincides or heads coincides. So for example, this is tail, this is head for this vector B bar, and for A bar also this is tail and this is head. So you arrange the vectors such that the tails coincide or heads coincide. You can also draw heads coincide also. Then whatever the angle is formed between them, that is called angle between the vectors. Okay, and see, for finding angle between vectors you should also know about one property known as vector invariancy property. Okay, so what is vector invariancy property? Vector can be shifted from one point to another point, okay, without changing magnitude and what? Direction. So here, now for example, when vector A bar is here, I can shift this vector parallelly in this way. So direction not changing, length not changing, so magnitude not changing, direction not changing, vector remain the same. So for example, when vector here B bar, for example, okay, I can shift it parallelly here like this, I can shift it parallelly. So vectors can be shifted from one point to another point without change in magnitude and direction. This property is called what? Vector invariancy property, students. Okay. So here, so you can shift the vectors from one point to another point dimension, right? So now see here. Now I want to find the angle between these vectors. Look at board. So this is A bar. Another vector is here B bar. As I mentioned, you can shift the vectors like so. Just move this vector here A bar like this forward, such that tails coincide. No, so this is B. See, B tail is over here and its head is over here. So for A tail is over here and B head is over here. Okay. Now you have shifted this vector A bar, isn't it? So like that pulled forward so that these two tails are coincident. Now this angle is formed. No, this is angle between the vectors. Sometimes in the question he will mention, say for example, this angle is some 150 degrees. So now you know complete angle how much? Complete angle is 180. So when this is 150 gone, so this theta becomes how much now? 30 degree. Therefore angle between these vectors is 30 degree. Okay, so this example 1. Now for example, say example 2. For example, one vector is here like this, another vector is pointing in this way. Some L bar vector and so this is M bar vector. Again you can use vector invariancy property. So what you can do, so L bar you draw as it is, L bar, you shift this M bar, okay, leftward such that its tail coincides with this tail. So just shift it parallelly, so without changing magnitude and direction. Yeah, its tail coincides with the tail of the L bar. Okay, so yes, now the angle formed here is what? 90 degrees. So like this we find angle between the vectors. So for finding the angle between the vectors, you draw the vectors such that their tails coincides or heads coincide. Clear, students? Now, so coming for here, additions of vectors. See, types of vector we have seen: zero vector, unit vector, position vector, parallel vector, anti-parallel vector. I also mentioned equal vectors. Keep in mind, two vectors are said to be equal if their direction same, magnitude same. Any one of them change, no, definitely vector will change. Okay, so now and then we have gone for what? Angle between the vectors we have seen. So next we try to understand about addition of vectors, students. Addition of vectors. Okay, so now coming for addition of vectors, how do we add? So as I mentioned before, definition itself, those physical quantities which have both magnitude and direction and should which obey vector addition laws, then only they are called vectors. If they don't obey the laws, no, it's not called a vector. Like electric current is there, no, so electric current has magnitude and direction. Okay, so but we can't say it as a vector. Why? So in a electric circuit you might have studied, for example, a battery is there, okay, a switch is there, a resistor, for example. When the switch is closed, what happens? Current flows, isn't it? Direction is there. How much current you can measure by connecting an ammeter in series here. Okay, some current of some 5 ampere. Yeah, magnitude is there, current is flowing in this one, so like this, understanding? So current is flowing, so direction is there, but it's not a vector because it won't obey vector addition laws. Now if you mold the wire in completely in circular fashion like this, some current is entering here. Okay, now again current is coming to some same location. No, the value of current will not become zero. Okay, according to polygon law, we'll talk in next classes here, like when you're adding no all these vectors, so this gives zero vector. Vector magnitude becoming zero, but current practically not becoming zero. So current is not obeying the vector addition laws. As a result, we won't define it as a what? Vector. It is a scalar physical quantity. Okay, so now for adding the vectors, basically we make use of two laws, students. One is called triangular law. Okay, so you can mention nothing like this. So triangular law, and one more is what you can call it as parallelogram law. What law? Parallelogram law. So first we talk about here triangular law, student. So whenever you want to add two vectors according to triangular law, you represent. So now for example, this one vector is there, A bar, okay, another vector is there, so B bar. You want to add these vectors, okay, according to what? Triangular law. So you just draw these vectors such that their tails coincide or heads coincide to form a triangle without changing magnitude and direction. So this is what? A bar vector, its tail and this head. You shift this vector B bar, then what angle is formed? Angle between the vectors. Okay, now you just represent them Okay, along the adjacent sides of a triangle. Okay, adjacent sides of a triangular line. Okay, along the two sides of a triangle taken in order. Okay, so this is A bar. Now this is B bar. Without changing magnitude direction, slightly draw what you can call. So exactly parallel you draw. Yes, this is parallel. So now represent, see, you are representing these two vectors, representing these two vectors A bar and B bar along the sides of a what? Adjacent sides of a triangular. Okay, triangle to A bar and B bar. Then the resultant is given by third closing side in reverse order. So this is A bar plus B bar. You represent these two vectors A bar and B bar along the sides of a triangle taken in order. Important. Taken in order. Same sense, say taken in order. Then the resultant of these is given by third closing side in reverse order. This is one statement. Okay. Now what happens are if I take in the same order, general question may arise. Okay, you can try to see now. See, this is A bar, this is B bar. Okay, as I mentioned, you are representing along the sides of a triangle taken in order. Yes, this vector is like this. Currently along the same order without changing magnitude direction. Okay, now resultant according to the definition you have seen that resultant is going to be what? Third closing side in reverse order. This is A plus B. Okay, so you can call it as some R bar, no problem. Now what happens, for example, if you take three vectors in the same order, if you take here, what happens? Huh? So A, B, I know. So for example, now this is A bar, you are taking, this is B bar, you are taking. If I take C bar like this, okay, actually A plus B is how? A plus B is like this, A bar plus B bar. Now A bar plus B bar like this, C vector which you are pointing here, right? This is opposite to this, and third closing side, this is A bar plus B bar. So here if you see, direction wise opposite but magnitude wise they are same. So you can say C bar is equal to, or minus C bar is equal to simply A bar plus B bar. So you can write down like this, A bar plus B bar plus C bar is equal to 0 bar. Okay, so now here whenever, see, A bar B bar resultant is A plus B is like this, but if any other vector C is there which represents another what? Opposite order, in the opposite sense, then sum of these, if I call A bar plus B bar plus C bar becoming how much? 0. So very important conclusion here in physics. Whenever three vectors are there, if they represent along the sides of a triangle taken in order, okay, their resultant becomes equal to 0. A bar plus B bar plus C bar is equal to 0, null vector. Okay, keep in mind. And whenever this condition happens, students, so you can also mention that, so you can represent these, okay, from starting one point. See here, for example, this is A bar, another vector is B bar, no? So vectors are invariant. You can shift this vector B bar from this particular starting point. Or you can say, for example, you can also mention like without changing magnitude direction B bar. And C bar is pointing like this, right? So from the same origin point, you can also represent without changing magnitude and direction. So whenever three vectors start from the same point, okay, and if they are forming a triangle taken in order, the length of the sides in order in the same sense, then their vector sum becomes equal to 0. Now, so here by using triangular law, we could able to find the resultant, how much its magnitude, okay, that can be found. So from triangle also you can extend here, but we'll specially define parallelogram law, and there we mentioned parallelogram law indirectly a kind of triangular law only. I will show you in diagram how it is. Okay, now you see, so here you can find how you are adding the vectors. So to add two vectors, A bar and B bar, we are representing along the sides of a triangle taken in order. Resultant is given by third closing side in which order? Third closing side in reverse order. Okay, A bar plus B bar is equal to C bar. Fine. Now you can say if A bar plus, okay, or you can say is question wise, you can say here is A bar is plus B bar is equal to B bar plus A bar is satisfied here. So for example, you have A bar, under vector you have B bar, say A plus B is this one, but B plus A is how? So B pointing like this, right? and A. How the A is? A is like this. So B plus A means what here? B bar plus A bar means you are adding A bar vector to B bar. So A bar vector to B bar you are adding. So B bar you can keep like this only as it is. You are adding A bar to it such that the tails should coincide, right? This is tail head, this is tail, and this is head. You shift this vector such that its tail coincides with head of this particular vector, what? B bar. So now what you do? This is B bar. Okay, you shift this vector here parallelly. Okay, now you see this is tail, this is head. So this tail is coinciding, okay, with what? Head of the vector on whom you are adding. This is it. So then now they are representing along the sides of a triangle taken in order. So resultant is given by third closing side in reverse order. So this is what? B bar plus A bar. Okay, now is A bar plus B bar is equal to B bar plus A bar? We thought it may not be, no? Is it true or not? So now you see, so it is actually what? True. A bar plus B bar is equal to B bar plus A bar. It is happening. Okay, see, A plus B magnitude is like this pointing, and similarly, so you can mention here B plus A magnitude also same. This is third side, this is also third side. Directions are pointing, so you can say vector addition is cumulative. Commutative, you can say here word. A bar plus B bar is equal to B bar plus A bar. Vector addition is commutative. Okay, similarly we can also prove vector, okay, addition also obeys what? Associative law. So A bar plus you can say like this, B bar plus C bar is equal to, you can also prove by using same triangular law, A bar plus B bar plus C bar. We can prove this one. Okay, now okay, this is about triangular law means what? How you are adding the vectors, and what is commutative property and associative property for triangle. Okay, just brief revision. See, the entire thing it takes for me time to make the videos. I will do it. So currently you can remember this one. Okay, now after this we try to talk about which law? So parallelogram law of vectors. Okay, now for so here that is parallelogram. See student, so here whenever two vectors are given, for example this is A bar vector given to you and this is B bar vector, you want to add these two vectors by parallelogram law. What you do? You just, without changing their magnitude and direction, you form these two vectors as adjacent sides of a parallelogram. Okay, so this is A bar. You just shift this vector B bar such that, okay, their tails coincide, students. Here tails or heads you can, but here do tails. Okay, when you make it here tails coinciding, right? This is head, this is tail, this is tail, this is head. So this is vector B bar. See, I'm not changing direction, almost same, and magnitude also same. I'm not changing by vector invariancy property. So this is angle between the vectors. Now you do how to form a parallelogram. You know property of parallelogram. What is property of parallelogram? Opposite sides are equal and parallel. So you draw for this A bar an opposite vector A bar like this. For B also you draw opposite vector B bar like this. Okay. So now, so when you are here drawing a parallelogram, you formed a parallelogram. So now opposite vectors equal and parallel. So this is also B bar and this is also what? A bar. So resultant is given by, so here a vector which is, okay, passed from this what? Common vertex. This is common vertex. So represent the two vectors A bar and B bar along the adjacent sides of a parallelogram with common vertex. Then resultant is given by, okay, this vector passing through this common vector, common point, you can say, common vertex, you can say. This is R bar. Okay, this is R bar. Now this is what this law is called, what? Parallelogram law. I will revise once. Just consider these two vectors as adjacent sides of a parallelogram. This is A bar without changing magnitude and direction. This is B bar. Form a parallelogram, draw parallel vectors. Parallel to A is A bar, parallel to B is what here? B bar. common vertex form, this angle is formed now. So when two vectors are represented along the adjacent sides of a parallelogram, then the resultant is given by, okay, diagonal passing through this common vertex. This is R bar. Okay, so this is what parallelogram law. So how to find here resultant? So how to find here resultant means, you see here, so just a small construction here. What do you do? So you draw a perpendicular here like this on this extended side of length A. Okay, now when these two vectors are parallel, this is also what, B bar. So when the center angle is theta, this is horizontal. So now these two are parallel, so this angle become corresponding angle, this also becomes theta, and this length is what, magnitude of vector B bar here, right? So now in this triangle, students, okay, if you take in this triangle cos theta, what is cos theta value? Adjacent side, say some x, by hypotenuse is magnitude of B here. So cos theta will be adjacent side by what, hypotenuse is B. So x becomes how much, student? X becomes B cos theta. Similarly, in the same triangle, you take sin theta. So why I am telling you, just you will understand in short duration. So this side, opposite side we want. So this is say y. Sin theta is opposite side in right angle triangle by hypotenuse, that is B. So y becomes how much now here? B sin theta. What is our aim actually? Our aim is to find the magnitude of this vector, right? Yes or no? So you can take this, say for example, this is O, fine. And this is A, this is B. Okay, so this is OC. So we want to find mod of OC. Yes or no? That is what, R bar magnitude. Now take triangle OC. Say you can take this perpendicular as M. So from triangle OCM, so OC square is equal to OM square plus MC square. OC is R, so R square is equal to OM. OM is OA plus AM. OA is A, OM is X, so you can say A plus X. So A plus X whole square plus MC is Y, which is equal to Y square. You can write R square is A plus X value how much? B cos theta. X value is B cos theta whole square plus Y value how much? Y value is B sin theta whole square. So now R becomes R square. Expand the bracket, A square plus B square cos square theta plus 2AB, no? So 2 into A into B cos theta, 2AB cos theta plus one more term, B square sin square theta. Okay, so now what happens? R square becomes now A square plus, in these two take B square common, so sin square theta plus cos square theta is 1, so plus 2AB cos theta. Now you got R as this square becomes now root, under root of, right, A square plus B square plus 2AB cos theta. This is the resultant of two vectors. Now summary, see, now when this vector is A bar and this vector is here B bar, angle is theta, so you form a parallelogram, parallel to A, parallel to B. Resultant is given by what? Diagonal passing through common vertex. This is R bar. Its magnitude is given by R is equal to root of A square plus B square plus 2AB cos theta. Okay, so now here we can talk about here cases. Okay, now what are those cases means? Here you can see, now when theta is equal to 0 degrees. Okay, so the components and product, cross product, one more session I will make. Okay, so now currently you can see only, so when theta is equal to 0 degrees means they are parallel vectors, A bar and B bar. Theta is 0 degrees, so R becomes simply how much, friend? So you can cos 0 value how much? Cos 0 value is 1, so simply becomes how much? A square plus B square plus 2AB, which is equal to under root of A plus B whole square, simply becomes A plus B. That means simply magnitude of A and magnitude of B. So when two vectors are pointing the same direction, simply add their magnitudes. This is the conclusion. Okay, if they are in opposite direction, you can mention if theta is 180, for example, here you can draw. So one vector is like this, another vector is like this. Angle between the vectors is 180. Okay, if you produce like this forward, this is backward like this, straight angle. Put cos 180 here. Cos 180 becomes minus 1. So a square plus b square minus 2ab. A minus b whole square. So we'll get what? Resultant becomes simply what? A minus b. A minus b. So conclusion, when two vectors are in the opposite direction, simply subtract their magnitudes. Mod of r is mod a minus of mod b. Okay, third case you can talk now. If theta is 90 degrees, all of you know Pythagoras theorem, that conclusion will come now here. So this is a bar vector, this is b bar vector. Resultant is given by, okay, triangular law means a plus b like this, or parallelogram means you can form this is a, this is b, you can shift parallelly, parallelogram form, vertex you see like this. Okay, this is mod r. So how much now? This is a and this is b. Angle is 90 degrees. So cos 90 is how much, student? Here cos 90 becomes 0. So simply r becomes how much now? R becomes root of a square plus b square. Are you getting? So these three cases we have seen. So maximum value is a plus b. Okay, minimum value is here a minus b. So vector value lies between what? A plus b and a minus b here. Therefore mod r value is lying between what? Mod a plus mod b and what? Mod a minus mod b. So this is what r is lying between minimum and maximum value. Okay, so we'll end up the session over here. So up to addition of vectors, okay, multiplication of vectors, components, one more video I will make for you. Okay, thank you all. So now you can see here whatever we have done so far. What are vectors, types of vectors, representation of a vector, purpose of vectors, okay, and then we have seen examples, then types of vectors I defined. Okay, then we talk about unit vector concept and its direction. We spoke about position vector, and in addition of vectors we talk about triangular law, and we have done what? Parallelogram law, and the cases, okay, theta 0, 180 and 90 degrees cases, and are lying between what? Mod of a plus b into what? Mod of a minus b. So what you can say here, last sentence you can see here, parallelogram law, are lying between mod of a plus mod of b and mod of a minus mod of b. Okay, this what here, students, resultant vectors. Okay, so r is equal to root of a square plus b square plus 2ab cos theta, and when theta 0 degrees, r is equal to root of a square plus b square plus 2ab. That means we yielded into this result. R is equal to mod of a plus mod of b. We have seen when vectors are in the opposite direction, we have seen r is equal to mod of a minus b. We have seen this result. We have seen when theta is 90 degrees, so we have seen this result, r is equal to root of a square plus b square. Okay, and the value of r lies between these two. Now 1 minute, 1 second, you see. So when you have two vectors, this is a bar vector, this is b bar vector, and when theta is the angle between them, and we represent them along the adjacent sides of a parallelogram with common vertex, and we designed a parallelogram parallel to a, this is a bar, parallel to this is b bar. The resultant is given by diagonal passing through the common vertex. Okay, this is r bar we have seen, and for finding the magnitude of r, we have seen that we have drawn a perpendicular here, say for example some m, and let's say r bar makes an angle alpha with what you can call a bar, and beta with what? You can say b bar. Now in this one, so this vector you have seen as b, why? These two are parallel, you can say, and when this angle is theta with the horizontal, so this is also b, so this also makes angle theta, and we have seen this magnitude is b, right? And we have seen this value x we have derived, and this value as y we have taken, and this x we have derived as b cos theta, and y we derived, okay, you can go through my previous session. So y is equal to b sin theta, just nothing, right angle triangle we have taken, and this angle theta, this is b, this is x, this is y. So we have written cos theta is equal to x by b, and x is equal to b cos theta, and similarly y is equal to b sin theta. This derivation you have done. Now let the resultant makes an angle alpha, we are saying, right? Yes or no? So resultant angle vector is making an angle alpha. So in this triangle, say this is O, this is A, okay, this is C, you can say this is B. So OCM, right angle triangle. So what you can get tan alpha value? Tan is what? Opposite side by adjacent side, yes or no? So opposite side by adjacent side, tan alpha. Opposite is b sin theta. So b sin theta a divided by a plus b cos theta. Why a plus b cos theta? OM. Opposite side is in this triangle. Opposite side is b sin theta. Adjacent side is this vector is a. This value is b cos theta. This vector magnitude is a mod a. So a plus b cos theta. So we have seen now tan alpha is equal b sin theta by a plus b cos theta. So you can write alpha as tan inverse of b sin theta by a plus b cos theta. We have seen, students. Okay, this is the angle made by resultant vector with any one vector. Clear? Now, so here you can make this tan alpha equation as 1. Now we can also prove here, students, if two vectors are of equal magnitude, if a is equal to b, if you simplify this one, so tan alpha is equal to, so this is a is equal to b or calling, so b sin theta by a is equal to b, so b plus b cos theta, so you take b common, so 1 plus cos theta, you can cancel this. Sin theta you can write sin 2a formula. See, so sin theta you can write like this, sin 2 into theta by 2, can you write? This to get cancelled. So you can take sin 2a form. Sin 2a formula is 2 sin theta cos theta. Sin theta, theta means theta by 2. This is cos theta by 2 divided by 1 plus cos 2a formula, students, here again. So I am going to use 1 plus cos 2a formula, 2 cos square a. Okay, we should know these formulas. Formula 1, formula 2. Okay, now if you substitute these values, 1 plus cos 2a is 1 plus cos 2a is 2 cos square a. When this is 2 theta, this is becoming theta. Okay, so here theta is, that becomes theta by 2. So 2 cos square theta by 2. This is called half angle identity. Okay, so sin 2a formula is 2 sin a cos a. 1 plus cos 2a formula is 2 cos square a. So when this is 2a, it becoming a half. So this is theta and it becomes half, theta by 2. When you simplify, students, 1 cos theta by 2 get cancelled. So you can write down now tan alpha is equal to tan theta by 2. Whenever two trigonometric functions equal, okay, there means trigonometric identity is equal, you can write on their arguments, angles also equal. So from this we understand alpha is equal theta by 2. So when two vectors are of equal magnitude, okay, like this a bar and this is a b bar, parallelogram, again this is a, again this is b. Okay, this angle theta, resultant is r. Now and this angle we made as alpha. Now what is saying conclusion? When this a is equal to b, what we have drawn? Alpha is theta by 2. So this will become half theta by 2. Total angle is theta. When this is theta by 2, this also becomes what? Theta by 2. What does it mean? That means resultant is bisecting the vectors. Very important result. Whenever two vectors are of equal magnitude, what does resultant will do? Resultant will bisect the angle between the vectors, students. Okay, simply you can take one vector resultant. So for example, 10 Newton magnitude, 10 Newton magnitude are there at an angle of 60 degrees. Okay, so find the angle made by resultant vector. He may ask tomorrow in the exam. So what you can write parallelogram. So you can say this is a resultant passing through diagonal, right? Now formula is what? So theta is equal to 60 degrees. How much resultant makes angle? Alpha. So tan alpha is how much now we have written? After if a is equal to b, tan theta by 2 we have said. Yes or no? So alpha becomes theta by 2. So simply this becomes now 30 degrees. In this case, what is resultant if you ask? Resultant how much? What is the formula for resultant? R is equal root of a square plus b square plus 2ab cos theta. A is equal to b also, isn't it? These two vectors are equal. So a is equal to b. Now you can say a is equal to b. So you can take a square plus 2a into a, again a square into cos theta. So you can take, student, 2a square. Here 2a square, to take common. So 1 plus cos theta. Again same formula I am going to use. 1 plus cos 2a. Formula is 2 cos square a, half angle identity, 2a, it becomes a. This 1 plus cos 2a. Theta I am writing how, students? 2 into theta by 2 form. Okay, so now you can understand. So which is equal to how much? 2a square into 1 plus cos 2a formula is 2 cos square a. A means theta by 2 here now. Why? So half angle identity. So 2 2 is 4, root 4 is 2, root a square is a, cos theta by 2 whole square is cos theta by 2. So you can write down here cos square theta by 2 is equal to cos theta by 2 whole square. You can write like this in trigonometry. So when two vectors are of equal magnitude, resultant will be how much? 2a cos theta by 2. Now here each magnitude is 10 Newton. So 2 into 10 into cos. Angle how much? 60 degrees. Isn't it? How much angle I give? 60 degrees. So you can 60 by 2 is 30 degrees. That is equal to 20 into cos 30 is root 3 by 2. 2 ones are 2 tens are. So 10 root 3 Newton. So when two vectors are of equal magnitude, resultant bisect the angle. Okay, one point important one. Second point is the formula for resultant. You have to remember this formula throughout these 2 years of +1 and +2 and for competitive exams. Okay, 2a cos theta by 2. This is how we find the resultant of two vectors. Parallelogram law of vectors. Okay, and next we are going to enter into a very important topic, what we can call is components of a vector. So simply remember, component nothing but in mathematics language we call foot of the perpendicular. In general, okay, non-scientific language you can call it as shadow of something. Okay, or one more point, projection you can say. In physics the same thing we are calling as component. So before understanding this, simply understand this one, student. For example, I have a pole like this with a horizontal making some angle theta. If it's sunshine or some light, if you are making it to fall on this one, how it shadow falls? Come on, tell me. Yes, the shadow falls like this. This is called projection. In vector, this itself we are calling as component. Clear? Now say we are having a vertical wall here like this. Same pole is standing like this. What you do? You just sun the light or switch on the torch light like this. Where is shadow fall? Its shadow falls on the vertical wall. So this intercepting length is called local language shadow, scientific language projection. In mathematics, in physics, we call component. So if you see that this particular rod or this particular pole is lying in the xy plane, its shadow along x direction is called x projection. Shadow along y direction is called what? Y projection. So you can say a vector in the plane, it can be resolved into two perpendicular components. We call this as rectangular components. What, students? Rectangular components. Okay. So what about if this pole is lying in the space or in vertical plane, you ascend it, right? Now if it lies actually in a space, so you can have three directions. So this is x-axis, y-axis, and we have z-axis. If it is in the plane or a space, so if you draw a light or when you shine the light like this, you can fall its shadow on the x-axis, its shadow on the y-axis, and actually perpendicular to this, right? I cannot draw it as a plane, no, perpendicular. Imagine a z-axis towards your eyes, then its shadow on the z-axis. We can't draw, no, just I'm representing over here. Like this, a vector can be, say for this vector is a bar. Okay, length of the vector you can talk as a magnitude, length of this particular pole which you have taken. Direction is this one, so vector plus magnitude. Okay, this component projected length, this is x component, this is we call it as y component, this we call it as z component. Okay, so you can also talk here, for example, this angle is here alpha. Okay, this magnitude is here a, already you know cos theta. So cos alpha is how much, beta? Adjacent side by hypotenuse. So ax value how much? A cos alpha. Its length. And y axis how much? Again same, this triangle you can take here. Okay, so this angle you can say 90 minus alpha, or you can also take some other different. If it is in the space, you can take this result a bar vector making an angle of some beta with y axis. Then ay becomes how much? You can draw here ay is equal to, one side is ay, hypotenuse is a, So AY becomes what? Beta. A cos beta. Similarly, Z axis also you can write AZ is equal to A cos, say gamma angle it is making. So when a vector in the space, okay, makes some angle alpha with x axis, beta with y axis, and gamma with z axis, then the respective components are projected lengths along the direction is ax, along the direction is ay, along z direction intercepting length, okay, is how much? Az. Then ax becomes a cos alpha, ay becomes a cos beta, az becomes a cos gamma. These are called components. Okay, so now you can use triangular law for writing any vector in the space here. Okay, first we'll talk about how to write a vector in a plane into what? Its components. What are components? Whenever any vector is there, so component is given by, so simply one more way of saying this. This is tail, this is head. In which direction you want the component? Okay, it is student. So from the head of that vector, draw a perpendicular in the direction. Then the intercepting length is called x component. No sir, I want to find component y direction. Sir, yeah, please go ahead. This is a bar vector. Where is the head? This is the tail. From the head you drop a perpendicular on that particular direction. This intercepting length is called y component. Similarly, this is z direction, this is x, this is y, this is z, right? This is y, this is z. So this is not in the plane, perpendicular to plane. So perpendicular to plane means towards you can imagine a perpendicular. Then draw from head one intercepting length. So this is a plane, I can't draw here, that's why you have to imagine here. So z direction you can say. Then this intercepting length is what? Az. Then ax, ay, az already found, a cos alpha, a cos beta, a cos gamma. If I take r cos alpha, r cos beta, r cos gamma, understanding? So these are called components of the vector. Now okay, so a vector, this is in a space. So in space, a vector can be resolved into, okay, three perpendicular components called rectangular components. So a vector in space can be resolved into how many perpendicular components? Three perpendicular components. So three rectangular components. If I ask vector is lying in a plane, they are called coplanar vectors. Okay, vectors lying in the plane. Same a bar or r bar as you wish, student. Okay, this is x, this is y. If this angle is alpha, if I draw a perpendicular, this intercepting length is x component. So rx becomes how much? R cos alpha. If I draw a perpendicular, this becomes ry. So this angle you can take as beta, or a plane, no, this angle is 90, this becomes 90 minus alpha. So you can also write r cos beta, but beta is equal to how much? 90 minus alpha. So you can write r cos beta means 90 minus alpha, cos of 90 minus theta, that is sin alpha. Okay, remember this formula in mathematics. Fine. So r cos 90 minus theta is equal to cos of 90 minus theta. Okay, this is y component, sin alpha. So beta is 90 minus alpha, so cos of 90 minus theta, no? So you can write, this is when rx, this is when ry is r cos beta, rx is how much? R cos alpha. So beta value is 90 minus alpha, so cos of 90 minus alpha. So which is because how much ry will be? Ry becomes r sin alpha. Clear? So here a vector in the plane is resolved in two rectangular components. So this is x component. Components are scalars. Okay, keep in mind, vector is there, vector components are what? They are scalars. So here r bar, rx and ry. Now see, I can write down this particular rx length and ry length in terms of unit vectors here. Now one before this, how to represent this r bar in terms of its components. So for that, remember students, already we discussed about unit vectors, right? What are unit vectors? Those vectors which are having magnitude equal to 1 are called unit vectors. So especially we are defining a three vectors, okay, in space. This is x, this is y, z. Any vector, if it is pointing along x direction, already we have seen unit vectors are utilized for finding direction, most important point. So let's say unit vector in x direction is I cap. This is standard notation. Unit vector in y direction is j cap. Unit vector in z direction is k cap. For example, a car is moving along x direction with a velocity of 10 meter per second. We call. How do we write this one? Simply, instead of saying this big sentence, simply v bar is equal 10 into I cap. It means a car is moving with a velocity of 10 meter per second in x direction. Okay, a ball is projected vertically upwards, that is say y direction, with a velocity of 5 meter per second. Then you can simply write velocity in y direction is equal to 5 meter per second y, no? So simply write j cap. So instead of saying big sentences, make vectors makes, okay, our task very simple. Phi j cap. Okay, so like in future we'll asking electric field this direction, magnetic field that direction. You can make use of these unit vectors. Now here I can write down now. So in x direction I want to raise, so the component is a scalar and I am assigning direction to it, so I cap. So component in y direction ry cos r cos beta is a magnitude scalar. I am assigning direction j cap, and I will be using here triangular law. So this is rx length into vector rx into I cap. This is a vector along x direction. So this is ry is magnitude, okay, and I'm assigning direction into j cap. Magnitude into direction is a vector now. So I'm having a one vector rx into I cap, under vector ry into j cap. So resultant is given by triangular law, third closing side in reverse order. This is what r bar, and this angle we are calling as r cos alpha. Therefore, I can write now r bar as triangular law, a bar plus b bar, that is rx into I cap plus ry into j cap. Okay, student. So the same vector, if it lies in the space, how we will write? Yeah, very simple. This is x, this is y, z is perpendicular. I can't draw perpendicular here, no? So rx plus ry resultant is this one. This is rx, this is ry, this is resultant of rx and ry. So rx plus ry, rx bar also you can call y, rx into I cap is rx bar, ry into j cap is ry bar. Okay. Now, so z is perpendicular to this x and y planes, right? So this is now resultant of what? Rx into I cap plus ry into j cap. Z is perpendicular to this two, no? So for example, I am drawing perpendicular to this. Z component is rz. So I am saying k cap. Resultant how much now? All these? This is resultant. So when a vector is in a space, this is r bar. Its x component is rx, y component is ry, z component is rz. And if this angle makes alpha, this angle is beta, some angle is here gamma. So perpendicular on this gives x component rx, perpendicular on this gives y component ry, perpendicular on this gives rz, students. So I can write down this vector in terms of its three components, rx, r bar is equal to y. Again, this is, you can say a bar, this is b bar, this is resultant, isn't it? So a vector can be resolved into its components, okay, and can be written in its component form. Therefore, I can simply say this rx is called x component, ry is called y component, rz is called z component. Okay, so this is how we can write a given vector into its component. For example, we have a vector in the space a bar. I can write as from 2 I cap plus 3 j cap plus 4 k cap. Now, can you tell me, students, what is 2? Its projection along x-axis is 2, so x component. Projection along y-axis 3 units, that is 3, y component. Along z direction, okay, z component. So what is magnitude now? Very simple, you can find out now. See here, simple formula I will give. X along x length is 2 units, along y length is 3 units. Can't you find this resultant length? Yes, by Pythagoras theorem you can say, or triangular law magnitude you can say, isn't it? These two are perpendicular, no, root a square plus b square, yeah, root of 4 plus 9, right? How much? Root 13. And perpendicular to the z component, how much length is 4. Now you can find resultant, how much will get? This is resultant now. How much? This is under root of, this is root 13, no? Now this value becomes root 13 whole square is 13 plus 4 whole square is 16, becomes root 29. So indirectly what you are doing, you are simply its magnitude you are finding. Okay, all you see, this is root x square plus y square, x square plus y square. Okay, and this is 4 square you are doing, means z square you are doing, isn't it? This is z square. So simply if x, y, z is there, its magnitude is simply under root of x component whole square plus y component whole square plus z component whole square, which is how much, students? Come and tell me. That will be 4 plus 9 plus 16. 13 plus 16, how much, right? 29. That is what you got the answer. Okay, so like this, by using components we can find the resultant of the magnitude. Okay, that's what we are saying. And now I will summarize these components. You can see now. So whenever n vector is there, a bar, anyway you can take x component, if this makes angle theta, draw a perpendicular, this intercepting length ax is a cos theta. In y direction you want, draw a perpendicular on y axis, this is ay. Ay value how much? A sin theta. Yes sir, what is magnitude? Mod of a root of x component whole square ax square y component whole square ay square. One problem also we have done just now. Okay, this is what the components of a vector x component, y component and z component. And one more point, actually generally this one you can understand very easily. For that matter, a vector can be resolved into any number of components. How sir it is? Say for example, this is a vector. Okay, some r bar or some a bar, doesn't matter. So I want to resolve this vector in this direction. What I said, from the head of the vector draw a perpendicular in the direction. This is, so for example, direction 1. This is say a1 length. No sir, I want to find vector component in this direction. Which direction? So for example, this direction 2. No problem. From the head of the vector you draw a perpendicular. So this is called intercepting length along this direction. So I can call component of vector A along direction 2, a2. Sir, I want to find component vector along this direction. Okay, beta, no problem. So this is 3 direction. Yeah, I simply draw a perpendicular in the direction 3. So draw a perpendicular. This intercepting length. No sir, I want to find this direction. No Baba, you can draw, no issue. Draw perpendicular. What did you understand? Like this, in any direction you can find the component of a vector. Okay, so for that matter a vector can be resolved into infinite number of components. Okay, a vector can be resolved in any direction. So how many components will get? You will get infinite components. But in a plane, two perpendicular components, only two. They are called rectangular components. In a plane, two. In a space, how many rectangular means perpendicular, how much? 3 components. For that matter, normally you can resolve vector in any direction. Okay, this is what students regarding components, how to find components. Okay, resultant, fine. So good. Next, the last part of the vectors we are entering now, that is called dot product and cross product. This is a vector product you can call. Vector products. So these vector products are classified in 2. The first case is called dot product. A result is scalar, and then this is also called scalar product. Okay, so if two vectors a bar and b bar are there, you can simply write this a bar dot b bar is equal to a is mod a, this is b is mod b cos theta. So simply you can write a bar dot b bar is mod a mod b cos theta. We resolve like this. Okay, result is a scalar, so what product? Scalar product. So now two vectors are like this, fine. Now scalar resultant is a scalar, so you can also write this one as simply a into b cos theta. Okay student, so for example one vector is there, fine, or you can also see b into a cos theta, no issue, both are same here. Students, here b bar dot a bar, you can define definition now, mod b mod a cos theta, b a cos theta. A into b is b into x. This is also equal to ab cos theta. But ab cos theta is a dot b, which is equal to a bar dot b bar. So vector scalar product, you can say, okay, dot product is commutative. Okay, it's physical means try to understand. You keep in this mind point. Okay, so keep in mind this point. Now coming for this a bar vector, say for example this is b bar vector, angle between them is theta. Okay, so now simply already just now you have seen a dot b is ab cos theta. So what is cos theta now? Cos theta is equal, simply from this equation what you can write, mod a mod b, sorry, a dot b, no yeah. So From this vector you can write simply now. So cos theta is equal to, this is b bar we said from this relation 1. So cos theta is a bar dot b bar by mod a mod b. Mod a is a, mod b is b. So whenever you want to find angle between vectors, you can use this relation. So cos inverse of a dot b by ab. Simply remember this formula. So whenever someone asks you to find the angle between two vectors, just cos theta a dot b by mod a mod b. For finding angle between the vectors, we're making use of what? Dot product. Simply cos theta is what you can say, a dot b by mod a mod b. This is one application you can say for finding angle. Second application you can also find, okay, like in physics we come across, we want to find work done. A body is there, a force is acting on this body. This body undergone displacement like this, okay, some theta. Angle between the displacement vector and force vector is some theta. Then work done by this force is defined as scalar product of force vector and displacement vector. Similarly, power. What is power? Rate of doing work. So we can call average power here F, total work, total time taken, average power. So F bar dot S bar by T. So F bar dot displacement by time, total displacement, total time taken is called average velocity. Okay, so generally we talk instantaneous power, that is dw by dt we call. So we'll understand that is F dot S divided by R. F dot ds by dt we call small amount of work. So you can call F bar dot ds by dt is called V bar. F dot, this is called instantaneous power delivered by the vehicle. Okay, now dot product. So we are having applications of what? Dot product result is a scale. And projection angle between vectors also we can call projected one vector in the direction of the other vector. This is also important application. For example, we are having a bar vector and this is b bar vector. If I ask you what is the component of a in the direction of b, what I said, simply drop a perpendicular in the direction, drop perpendicular. Yeah, this is 90. Okay, so we want to find this intercepting length. This vector is b bar is pointing like this, a bar is pointing like this. What is the component of this in the direction of b? In the direction of b, what is b a, on the direction of, see, in the direction of b, no, so on that direction you draw a perpendicular. So draw perpendicular, intercepting length. So this is component. So what you can get, whenever vector already we have seen just now, a, if this angle is theta, so perpendicular, so this intercepting immediate adjacent becoming what? Cos, a cos theta. Perpendicular is becoming how much? Yes, a sin theta. Now component of a in the direction of b, component of a bar in the direction of b bar, in the direction of what? B bar. How much better now? A cos theta. Okay, so but a bar dot b bar value how much? A b cos theta. So what you can write now? Yes, simply you can write down now a cos theta value from this one. So from this one a cos theta value you can write as how much? Therefore component of the direction of b bar, a cos theta I want, so a cos theta I want. So this transfer this side, so it becomes a bar dot b bar by b. You can write simply a bar dot b cap. So what is this one I am writing? Yes, component of a in the direction of what? Component of in the direction of what? Direction of b bar is a bar dot b cap. So component of in the direction of b, always direction is going to be unit vector, so I can say b cap. So component of the direction of b bar is a bar, it's meant to dot b cap. Similarly, if I ask component of b in the direction of a, yes, component of b bar in the direction of a bar, yes students, in the direction of a bar, what you have to do? This direction of a, right? Draw perpendicular from b bar on the direction of a. So this intercepting length is called component of b in the direction of a. So if this is theta, if you want, this becomes what? B cos theta. Draw perpendicular, adjacent becomes what? Cos. Perpendicular becomes what? Sine. If I consider this direction, no, it becomes sine, isn't it? So this becomes cos. So b cos theta. So simply this is b cos theta. Again from this relation, b cos theta how much now? B cos theta, no? So transfer this a this side. What will have? A bar dot b bar by a. So A bar dot is equal B bar dot A divided by A. So you can write B bar dot A cap. So if I have a vector A bar, this is vector B bar, this angle is theta, component of A in the direction of B, draw a perpendicular. This is intercepting length. This is called A bar dot B cap. Similarly, no sir, I want to find component of B in the direction of A like this. So draw a perpendicular. This intercepting length is called what? Component of B in the direction of A, in the direction of A, in the direction of A. So A cap. So B bar dot A cap. This is how we resolve the vectors into what? It's components, X component, Y component, okay? And from the dot product, we found the value of component of the direction of B, A bar dot B cap, component of in the direction of A, B bar dot A cap, okay? All these things we have seen, okay? And I will have numericals also, don't worry, we'll do numerical session also, right? So now this is about dot product. Now one more important point now we're having, okay, that is called cross product. This is also called vector product. Students, I am going to make one more video also on basic exclusive numericals, okay? Don't worry, I have taken it then few numericals. Again we'll take one more session also, don't worry. So cross product. So now A cross B is defined as cross product. It's called vector product. Why? Result is a vector. So if A bar and B bar are two vectors, just remember the definition. How A cross B is defined. We call word. This is written as cross. How you should read? Not A into B. We should read as A bar cross B bar. A bar cross B bar. Okay. Defined as that is mod A mod B sine theta. Okay, now these are all scalars, no, but what you are calling result as vector, no, so direction is given by unit vector n cap. So when you have two vectors A bar and B bar, cross product is defined as what? A bar cross B bar. And how much its magnitude is defined as? A bar cross B bar value is A bar cross B bar is mod A mod B sine theta into n cap. What is n cap? This is a direction. Whose direction it gives? Unit vector in the direction of whom? We are talking about whom? A cross B, yes. In direction of A bar cross B bar. Okay. If I take magnitude of this, so mod of A bar cross B bar. You know, the scalar magnitude only. This is mod of A is A, mod of B is B, sine theta is sine theta, mod of n cap how much? 1. So into 1. So magnitude of A cross B is equal to simply AB sine theta. How much, students? AB sine theta. Right. So now then, so we talk about after this magnitude, okay, direction we have to talk. Why? Because we are defining it as a what? Vector. Yes or no? So direction is given by, okay, right hand rule, students. Direction is given by whom? Direction of A bar cross B bar is given by right hand rule. Very simple. Okay, all of you take your right hand, okay, stretch the fingers. Look at me first, I will explain here. Say for example, this is A bar, okay, this is B bar. Then stretch the fingers of, okay, this is your hand, okay, stretch the fingers, this all these fingers in the direction of first vector A bar. This angle theta, no? Yes. Then what you do? This vector is now A bar. This vector is what? B bar. Then rotate the fingers from A to B. Okay, you should practice this one. So first take your vectors, okay, and make your palm parallel to A, okay, in the direction of A. Then curl. Curl means rotate into the plane of the paper. Okay, fine. That means towards B. In the plane, no, it is. So A to B, how to rotate? When you rotate from A to B, okay, so then it A cross B gives direction of the thumb. So now just look at me, I will explain you how it is. Okay, A to B hot rotate. So A cross B, thumb give direction of A cross B. Okay, so now you can understand. So white vector, this white pen is A, this pen is, say for example, B. At some angle they are existing. You got to move A to B. Okay, A cross B we have to do. That is called A cross B. Fine. Here A cross B, right? Look at me. So A bar vector, this is B bar vector. So A to B, A cross B gives from A to B. thumb gives direction of A cross B. So when you point from A to B, no, perpendicular to these two students, this is A bar, this is B bar. So this is also A bar, this is also B bar, A cross B. This is a plane, in say for example, this is a plane, horizontal plane. So A to B, you are rotating your fingers, A to B, A cross B. A cross B is upward, perpendicular to this one. Okay, both of them, plane also. This is direction of N cap, whose direction is given by A cross B direction. Okay, so right hand rule, A bar cross B bar. Curl the fingers, rotate, stretch the fingers of your right hand, the direction of vector A bar, then curl towards B bar, then thumb gives what? Direction of A cross B. This is perpendicular to B, perpendicular to A, and also plane formed by A and B, also perpendicular. Okay, this is about what? A bar cross B bar. Its magnitude how much given? AB sine theta. So if two vectors are perpendicular, if theta is 90 degrees, how much you can use now? If theta is 90 degrees, yes. So theta is 90 degrees. We can call A bar cross B bar is what is that magnitude? So if I take magnitude AB sine theta, AB sine 90. So simply A into B. Okay, this is maximum value. Now A cross B value when theta 0 or 180, that is called minimum. Why? Sine 0 is 0, sine 180 also 0. So AB into 0 becomes how much? 0. This is minimum value. Okay, maximum and minimum value of A cross B. So where we make use of its applications. Chapters comes, we'll understand better. Now currently remember formulas here. So now torque defined as torque tau bar is equal to R bar cross F bar. This is the force which causes turning effect in a body. So separate we have to make session for this. In rotational mechanics we'll talk about this. Okay, so turning effect, the force which causes turning effect is called what? Torque. Okay, now similarly angular momentum, this is defined as cross product of R bar vector and P bar vector. What is P bar? Linear momentum. So cross product of R bar cross P bar is angular momentum. Another call we have here, V bar is called omega bar cross R bar. Linear speed is given by angular speed, okay, angular velocity and R bar, their cross product. So these three applications we'll find. Okay, again more are there. So in the second year we will learn about force on a charged particle, all those things, don't worry. So we can call Q into V bar cross B bar. This formula in second year we'll understand force on a charged particle. Let's we come across applications, wherever applications are there, there we discuss in detail, not to worry. So this application of what is his cross product. Now, so two methods how to find cross product and dot product. So we'll exclusively talk, okay, for 5-10 minutes now. Okay, look at me. How to make use of dot product, how to calculate dot product. So before the students and then cross product, we define definitions, right? Now you see dot product and cross product. So for example, I will take component form. Say A bar vector is A1I, okay, plus A2J plus A3K, and B bar vector is B1I plus B2J plus B3K. So how to find A bar dot B bar? Okay, now as we mentioned before, I, J, K are vectors along x direction, y direction and what? Z direction. So already we have seen if theta is 90 degrees, A bar dot B bar is AB cos 90. So when two vectors are perpendicular, dot product becomes how much? 0. Okay. Now you can make, so A1I plus A2J plus A3K dot B1I plus B2J plus B3K. So it's normal multiplication, multiply every term to entire bracket. Okay, so A1 into B1, A1 B1, I dot I dot I mod A mod I cos theta, cos any vector will make how much angle itself, that is 0 degrees. Cos 0 is 1, so 1 into 1 into 1, that is 1. So I dot I is 1. Similarly you can write J dot J 1. Similarly you can write K dot K also 1. You have to remember these things. Okay. Fine. Now, so I dot I is 1. Similarly, A1 into B2, A1 into B2. See, I dot J, perpendicular vector, so dot product becomes 0, plus A1 B3, I dot K is 0, plus A2 B1 students, A2 B1, again J dot I, perpendicular vectors, dot product 0. Next A2 B2, J dot J, 1, right? A2 B3, perpendicular vectors, A2 B3, this is becoming 0, this is becoming 0. Okay, so A1 B1 over, so A1 entire term multiplication over, A2 entire over. Next last term A3 now, A3 B1 again dot product, perpendicular vectors K dot I 0. Next A3 B2 again perpendicular vectors K dot J 0. A3 B3 K dot K is, just now you have seen, K dot K is how much? 1. So if you see result, if I add only what is remaining now, A1 B1 plus A2 B2 plus A3 B3. This is what you have seen, dot product in component form. See, shortcut you can see here, simply multiply the coefficients, nothing else. X direction components multiply, y direction components multiply, z direction multiply. Just simply add them. A bar dot B bar, A1 B1 plus A2 B2 plus A3 B3. Okay, this is how you have to find dot product in component form. Similarly, now next we also talk, I mentioned what? Cross product in component form. So all the definitions we have seen. Now how to calculate. Okay, numerical also will cover, don't worry. So first of all, so for example, one vector is there, A bar. Okay, same you can take for example 2i plus 3j plus 4k you can say another vector say B bar, okay, is equal to 4i plus 6j plus 8k. I've taken some special example, I will tell you why it is. Okay, now how to define A bar cross B bar is the result, no? So keep in mind, so we just remember this method how we are doing. This is called determinant method. Okay, matrix determinant method. First write I cap, j cap, k cap students. Okay, here plus, you remember, minus, here plus. Why so? We will understand in a mathematics class in detail. For method remember here. Okay, so in first vector order is important. First vector is A, no? Take 2, next 3, 4. Second vector's components we take. This is 4, this is 6, this is 8. Okay, now matrix method we call. Okay, matrix determinant method. So now forget about just first row first column. Okay, when you write I cap, first row first column forget, write remaining elements. Okay, diagonal elements multiplication and difference. So 3 8s are 24 minus 24, 6 4s are 24. Next minus is here, no? So take minus j cap, same story. In which column, in which row j is existing, forget about that one. So this j in which it is there, column, row and column forget. Remaining elements what are they? Yeah, so you can say 2 and 8 and 4 and this one. So 2 8 is 16, 16, 4 4 is 16. So plus k cap you have to write. Okay, third the similar same story again, in which column and row k is there, forget that particular row and column. So this k you forget. Remaining elements 2 6 are 12, 3 4 are 12. Okay, so once again you can pause and listen the video. So 2 6 are 12, 3 4 are 12. So if you see, this is 0, this is 0, this is 0, so entire is 0 you are getting. So A bar cross B bar is 0, means you can also call null vector. Okay, whenever theta 0 or 180, sin theta becomes 0, we have seen definition, right? A bar cross B bar is what? AB sin theta. Theta 0 or theta 180, in both the cases result becomes 0. That means they may be parallel vectors or they may be what? Anti-parallel vectors. Cross product always becomes 0. So conclusion, when vectors are parallel or anti-parallel, okay, cross product becomes what? 0. When vectors are perpendicular, dot product becomes 0. Okay, this is what you have to remember in this case of things. Okay, so fine. So this is about dot product and cross product, students. Okay, now you can find out small few numericals here. Now let us focus few numericals here. Magnitude, this vector is given now, so this vector say A bar 3i plus 4j. What is magnitude of this vector? Root of 9 plus 16 root 25. How much beta? 5 units. Okay. Direction what we mentioned. See, this is a point in the space, like x component is 3 units, y component, y length along y direction 4. This point becomes how much now? 3 comma 4. So this angle is alpha. What you can write now? Tan alpha is opposite side by adjacent side, that is 4 by 3. Getting? Right. Now next you can see the dot product of I and j. Just now we have seen I is along x-axis, y is along what? J is along y-axis. They are perpendicular vectors. Perpendicular vectors dot product how much just now we have seen? 0. Very good. Fine. Next. Two vectors 6 and 8 at 60 degrees. Same question we have done. This is 6 newtons. Say for example, force if you call 8 newton. So parallelogram law, resultant is R. There at what angle? 60 degrees. What the formula for resultant? Root of A square means 6 square 36, B square 8 square 64 plus 2 into A into B into cos theta. Cos theta cos 60 is 1 by 2. You are following? Yes. This is 36 plus 4, 40 plus 60, 100 plus 48. How much will have? 148, 148. Right? Now, find unit vector along this one. No? Already we have seen unit vector definition. A cap is equal to what formula? A bar by mod A bar. So, unit when the direction of this vector means it's vector 3i plus 4j, its magnitude root 3 square plus 4 square. How much will have? 3i cap plus 4j cap by 9 plus 16 root 25, that is equal to 5. Okay. Same thing, this is 90 degrees root a square plus b square, direct formula, you can do it. See, dot product of the just now I said, so this is a bar, this is b bar. Okay, so a bar is 2i plus j, b bar is I cap minus j cap, dot product a bar dot b bar, multiply simply components. 2 into 1 is 2, so 1 into minus 1 is minus 1, so magnitude is 1 unit. Okay, cross product magnitude of two perpendicular vectors a bar and b bar. Okay, so two perpendicular vectors a cross b, ab sin theta, mod a mod b, simply projection of a on b when angle 60 degrees. Simply you can find, already we have seen projection, students. So this is a bar, this is b bar, angle is 60 degrees. Projection of a on b means draw perpendicular on b, so this length becomes what? A cos theta. Simply its magnitude will be given to you. Write down cos 60 is 1 by 2, that is a by 2. So already we have seen this one. Okay, like this you can make questions. Magnitude of vector, if you say this vector as a bar, what is mod of a will be? Already we have seen under root of component square, x component square 2 square, y component square how much? 3 square, z component square 6 square, root 4 plus 9 13 plus 36 root 49, which is equal to 7 units. Okay, unit when direction of I plus j plus k. I will get homework for you. You can do this. Direct I plus j plus k by mod root 3 will get, right? Yeah. Angle between equal vectors when resultant magnitude equals one vector. Say angle equal vectors, you can take any value. Say the unit vector 1 you can take. This is also equal vector 1 you can take. 1 you can take, some any 5, 10, any value you can take. Okay, angle between equal vectors when resultant magnitude equals. Okay, resultant also 1. So already we have seen when two vectors are of equal magnitude, what is the formula for resultant? 2a cos theta by 2. Derivation you can go back and you can check it. We have proved. What angle is asking, right? So resultant also equal to them. So a is equal to b is equal to r. If you take all of them are equal, so 1 you can take any value else, it doesn't matter. So 1 is equal to 2 into 1 into cos theta by 2. So 1 by 2 is equal to cos theta by 2. So when angles are equal, okay, for what angle this becomes 60 degrees? So cos theta by 2 becomes equal to cos 60. So theta by 2 is equal to 60 degrees. When functions equal, arguments must be equal. So theta is equal to 120 degrees. So whenever two vectors are of equal magnitude and the resultant also equal to one of them, then the angle between the vector becomes how much? 120 degrees. Okay, this is how basic numericals and quick revision I have done. Okay, so remember the formulas and all, practice well the numericals and all. Okay, so thank you all. So please like, subscribe and share this video and put comments also, how did you feel and solve the numericals. Okay, yeah, thank you all. Please do subscribe and like. Thank you all.